Okay, so I went ahead and drew a rough graph of the problem that we're given in the 2004 AP Calculus problem number 2. And so this whole graph is the graph of R, and we're given that, oh, I totally wrote an equal sign instead of a plus sign. We're given that R equals theta plus sine of 2 theta. And that's this graph right here. And we're also given that theta is greater than or equal to 0 but less than or equal to pi. And we're also given that r prime is equal to 1 plus 2 cosine of 2 theta. Cool. So let's start off with the first question. And it's asking to find the area bounded by the curve in the x-axis. So we want to find the area under this whole thing and then bounded by the line underneath the x-axis. So problem A, we're asked to find the area, and we're going to go ahead and take the integral because that's how you find the area underneath the curve, but we're going to keep in mind our limitations for theta, which is 0 and pi. So we're going to have area is equal to 1/2 times the integral from 0 to pi of r and then d theta. Can't forget that. We do know what r is, so let's go ahead and plug that in. So we have 1/2 of 0, the integral from 0 to pi of theta plus sine of 2 theta. And we're actually going to have r squared right here. So that would make this whole thing squared. And then don't forget your d theta. I went ahead and already plugged this into my calculator. So when you do that, you should get roughly 4.382. Okay, so I'm running out of storage on my phone, and I can't record long videos, so I'll try to get through this fast, but I did already do it. Part B, the question asks, find the angle theta that corresponds to the point on the curve with the x-coordinate -2. So we're looking for a theta value that corresponds to this point right here, -2 on our graph. So we know that we're going to have -2 in the equation that we need to create, and we know we're going to have r somewhere in there as well because we are using the graph of r. But we also need to we're supposed to find a theta value. So I set it -2 equal to r, our graph right here, times cosine of theta because we need a theta value. We already know what r is, so I went ahead and wrote that out. So I have -2 is equal to theta plus sine of 2 theta times cosine of theta. You can go ahead, I went ahead and plugged this into my calculator, the solve feature, and solved for theta, and you should get that theta is about 2.786. Okay, let's go to part C. So part C asks for pi divided by 3, which is less than or equal to theta, which is less than or equal to 2 pi divided by 3, r prime is negative. What does this fact say about r? What does this fact say about the curve? So basically what this is saying is, this is our graph of r prime. Here's pi divided by 3, and here's 2 pi divided by 3. In between these intervals right here, r prime is negative, meaning it's below the x-axis. So what does this mean for our graph of r? When your prime graph is negative, that means your, normal graph. It means that the slope is decreasing there. So for us, this means that r is decreasing in between pi divided by 3 and 2 pi divided by 3. This also means for our curve is getting closer to the origin for our graph of r. Yay. Okay, last one. So our final one, this is C. So our final one for D, let's leave this where I can still show it. The question asks, find the value of theta in the interval 0, which is less than or equal to theta, which is less than or equal to pi over 2, that corresponds to the point on the curve in the first quadrant with the greatest distance from the origin. Justify your answer. So we're going to be focusing on the graph of R, but just the first quadrant. So it should look something like this. I think it looks like that. It's almost like a circle, kind of. So we're actually going to use our prime equation. So our R prime equation is R prime is equal to 1 plus 2 cosine of 2 theta. So given that our limitations here are from 0 to 2 pi, because we're given that in the question, we're given that 0, which is less than or equal to theta, which is less than or equal to pi divided by 2. It means we're going to be trying to find a value for R prime in between this interval that is equal to 0. So we can check our endpoints, and then we can check a value or two inside. So let's go ahead and check R prime of 1 plus 2. Let's plug in 0. So let's do cosine of 2 times 0. And we're basically going to get that that doesn't equal 0. Cosine of... Okay, I have now deleted 4 apps from my phone so I can finish making these videos. I'm just going to start off, I think we left off here? I don't know. So we're checking the endpoints to see where R prime equals 0. So we have R prime is equal to 1 plus 2 cosine, and then we plugged in 0, 2 times 0. Cosine of 0 is 1, 1 times 2 is 2, 2 plus 1 is 3, so that does not equal 0. R prime, let's check the other endpoint, so R prime is equal to 1 plus 2 cosine of, those 2 cancels out, so cosine of pi, and that's going to be negative 1. Negative 1 times 2 is negative 2, and negative 2 plus 1 is negative 1, so that also doesn't equal 0. We're checking a point in the middle as well, so R prime is equal to 1 plus, we're checking pi divided by 3. R prime is equal to 1 plus 2 cosine, and then cosine of 2 pi divided by 3. That's going to equal negative 1/2. Negative 1/2 times 2 is negative 1, and then 1 plus negative 1 is 0. So at when theta equals pi divided by 3, R prime equals 0. So I'm going to quickly make a chart before my battery runs out, or before my storage runs out again. So we have theta, and we have R. We're checking R because this is our graph of R, and we want to find a theta value for R, not a theta value for R prime. So let's do check 0. So we checked 0. Let's plug in 0 into our R equation. That's going to be 0. When theta equals pi divided by 3, plug that into your R equation. I'll go ahead and write it up here so you can have it in front of you. Let's see, I lost my R equation. Our R is equal to... I have now deleted all of my apps, so I'm hoping that this works. So I was just giving the equation for R, and that's equal to theta plus 2 sine, plus sine of 2 theta. So if we plug in pi divided by 3, you can plug it into your calculator. I just think it's easier to work with decimals because you're trying to compare which one's bigger. I got 1.913, and then let's check our last endpoint, which was pi divided by 2. If we plug in pi divided by 2 into R, we should get about 1.571. So if we look at these values down here, we want to find which one is the greatest because we want to find which our value is furthest from the origin, and it looks like that will be pi divided by 3.